Hello, you're welcome back. All right, still Western function, and here we're going to be looking at different types, of functions. So we have these two different type of functions, and we're going to be looking at their difference. So now we start with the very first type, which of course is an onto function. Okay, so I'm gonna illustrate this function using a very simple term, right? Okay, so starting with the onto function. Now, onto function is also known as a surjective function. So when is a function said to be an onto? And a function said to be an onto function if the range of that function is equal to the codomain. Okay. So invariably now, it simply means that all the element of the codomain, is actually an image of the domain. So there's no element in the codomain that is not an image. So that simply means that the range, which of course we know what range is. Okay, range is the set of the images of the codomain. So the range is equal to the codomain. So please take note of that. So when the range of a function is equal to its codomain, then that is an onto function or a surjective function. Then we now have what is known as one-to-one function. Okay, now another name for it is injective function. Now a function is said to be one-to-one when the image of that function, the image of the domain, okay, is unique. That simply means that in the codomain there is no two elements of the domain that will have one image. They will always have their different images, unique images. So no one image of the codomain is actually mapped to two different elements, in the codomain. So that's what one to one. So everything is one to one. That's why it's called one to one. Of course, it's injective function. Now let me actually illustrate what I mean by one to one. Okay, so invariably now, if this function is one to one, I'm gonna map. Let's say I map a1 to b1. Let's say I'm gonna map a2 to b2. So every the mapping is actually one to one. Okay, there is no two element from A that is a mapped to a single element, in B. All right, so this is one to one. Now, but we also have what is known as bijective. Okay, so bijective is actually a function that combines that is both injective and surjective. So which simply means that a function whose range is equal to the codomain and the images are unique, then it's called a bijective function. So for example, this function quite well is one to one. I know very well. This function is one to one. This function, this mapping here is one to one, but it's not okay. Okay, yeah, it's one to one, and of course, also at the same time, it's one to one and onto. Okay, the function is one to one and it's also onto. So that means this function is bijective. Is bijective, one to one and onto. Okay, that makes it a bijective function. Why one to one is from what we see here simply means that the images are unique. Okay, the images of the code of the domain are unique, and at the same time the range of the function is also equal to the codomain. So but a situation where, let's say I have okay let's say, let me remove this. Let's say here now I'm having a b5 that is not actually mapped to anything at all. B5 is not mapped. Then invariably now I can simply say that yes, though this particular function is one to one, but is not onto. Okay, why? Because the range of the function is not equal to the codomain, so it's not one-to-one. So in that case, if it's not one-to-one and onto, so it is still going to be not bijective. It's not bijective. So I hope you understand the concept. Okay, so please take note of that. As we now proceed, we are going to be looking at the inverse function. Okay, how to find the inverse of a function. Okay. Inverse function. Now, of course, we already know that a function actually establishes a rule that maps element from the domain to the codomain. Okay, but what if I want to, this is a rule. Okay, let's say the rule is f of x being equal to, okay, some formula. Let's just say 2x plus 1. So this rule is a rule that actually gives me the element, or provides the range of my codomain, okay, based on the available element of the domain. Okay, this is the rule. But what if I want to actually reverse this? Okay, I want to actually reverse the rule to get from the domain now to my, from the codomain, please pardon me, to the domain. Okay, so the inverse of a function is actually the reverse of the rule, okay, which actually maps the codomain back to the domain. So that's why it's called inverse. That rule, okay, that actually maps the element of the codomain back to the domain is the inverse of a function. So that means you are going backward. Normally a function actually goes forward, right, from the domain to the codomain. But so if I want to move from the codomain back to the domain, then I am now, what I'm doing now is called the inverse function. So if this is let's say is the function f of x, then what is going to happen that takes me from b back to a is going to be the f inverse of x. Okay, so this is how we write the inverse of a function. So now the question is, how do we evaluate the inverse of a function? Okay, it's just very easy. It's just for you to rearrange that particular equation. Okay, then you can actually find the inverse of a function. I'm going to, let's look at some question. Okay, evaluate the inverse of the following. Evaluate the inverse of the following functions. Okay, so f of x, okay, let's start with this. Okay, 2x plus 1, then b f of x 3x minus 5. So solution. So for me to actually do this now, the simple step, let me start with a. Okay, you just gonna take some simple step, because what I'm doing now, I want to reverse this function. Okay, So reversing this function now, I'm going to interchange this. Now remember there are two variables, okay? Variable at the right hand side, which of course is the function itself. Then of course variable at the variable at the left hand side, which is f of x, the variable at the right hand side, which is x. So if I want to reverse this function now, I'm going to interchange the variable, okay? So this x now comes to the left hand side, then the f of x, okay, now, okay, changes, okay, the f of s. Now the x now is now being replaced by the f of x, but this time around, for that to happen, the f of x now would now change to f inverse of x. That's just what all I just need to do, okay? So making this f inverse of x the subject, that is my the inverse function, okay? So simply, you know how we do that. So that's going to be 2 times f inverse of x. Of course, you know what's going to happen. There's going to be x minus 1. So that means my inverse function now, f inverse of x, okay, is going to be equal to x minus 1 divided by 2. So as easy as that. Okay, let's look at this one. F of x, this is the b part of the question. F of x is equal to 3x minus 5. All right, let's do this. So the f of x, I'll replace it by x, and of course the x now is being replaced by f inverse of x. So I'm reversing this function now by making f inverse of x the subject. Of course, if I should make f inverse of x the subject, what I'm going to be having is x plus 5, then divided by 3. Okay, so what if let's say from this function now you're being asked to find the f inverse of 3. Simple, okay? So in this case now, since you have already find the f inverse of x, so to find the f inverse of 3 is just simple. Just replace x, okay, by 3 in this particular formula. So that's going to be 3 plus 5 divided by 3. Okay, so that's going to be 8 all over 3. So as simple as that. So I hope that is well understood. Okay, so we are going to the next subtopic. We're going to look at composite function. Composite function. Please pardon me. Okay, as the name implies, a composite function is function of a function. Let me okay, how do I illustrate a composite function? Let's say there's a function that actually maps a to b. Okay, then another function actually create another mapping. Okay, another function creates another mapping from b to c. So if I want to actually look at to move all the way, if I want to find a function that maps a, okay, to c, then definitely I have to combine these two functions. Okay, now let me not call this function f again, because this is a different function. So the function that actually maps b to c, let me call it g. Okay, g. The function that maps a to b, I call it f. Then the function that maps g to c, I call it b. I call it g. B to c, please pardon me, I call it g. Okay, so now if I want to actually get a function that actually maps a or from, okay, that maps a to c, then I'm combining these two intermediary function. So I'm going to combine both the function f plus the function g. Okay, so then before I could actually get myself, okay, uh, the function f and g. Okay, so that is the function that can now map me all the way from A to C. All right, now just in case this doesn't make sense, I will still illustrate. Okay, now let's look at a typical example. Okay, let's say you are being given two functions, the definition. Okay, two functions I have, let's say f of x is equal to 2x minus 1, and of another function g of x is 3x plus 2. So now these are two functions, and now you are being asked to evaluate okay a first of all the sum of these two functions. Let's start with the sum, f of x plus g of x. Okay, then of course b, you're now asked to evaluate the function that combines both f and g, then of x. Okay, then c, the function g of f, g plus f, right, then of x. So solution. Now the very first is not difficult. Simply you're adding these two functions. Okay, so that means invariably f of x plus g of x, all right, is going to be equal to 2x minus 1, then plus 3x plus 2. So collecting like terms, this is going to be 5x minus 1 plus 2, that's plus 1. But if we are not dealing with the composite function of f g of x, this is another way of writing it. Okay, so f plus g of x simply can be put this way. It is going to be f of, now remember I'm supposed to have f of s. Okay, so now f of s will now take the x, okay, of the f is now going to take g of x. So that's exactly what it means. That's what they call the function of a function. Okay, so in place of x of the f of x, so it is now being replaced by g of x. So now let's simplify that. Okay, already my f of s is 2x. Okay, so that's going to be 2. Remember, x now is being replaced by g of x. So instead of saying 2x, I will now say 2g of x. Then of course minus 1. Okay, so now let's now expand that. So this is going to be equal to 2g of x. Of course my g of x, okay, is 3x plus 2, then minus 1. Okay, so open this bracket, this is going to be 6x, right, plus 4, then minus 1. So this is going to be equal to 4 minus 1 is 3. So that's going to be 6x plus 3. As simple as that. Okay, so let me solve the other. Oh, please pardon me. I've claimed my question. Okay, so let me solve the. So let's look at this, the C part of the question. So here I'm actually working on G plus F, then of X. Of course, you know what that's gonna be. Okay, that's gonna be G of F of X. So the G of X now, the X of in the G is being replaced by F of X. Okay, so first of all, what's my G of X? My G of X is 3. So any place I see X is being replaced by F of X. Okay, all right, then plus 2. So this is going to be equal to 3 into what's my F of X? Of course, my F of X is 2x minus 1. Okay, then of course plus 2. So opening this bracket, I'm having 6x minus 3, then plus 2. So let's subtract this. This is going to be 6x, okay, minus 3 plus 2. That's going to give me minus 1. So that is function of a function. Okay, so as simple as that. Okay, so we're going to be looking at a typical examination questions. Okay, we're going to solve a lot of questions in the next video. Okay, so see you in the next video. Thank you very much.